Very good morning, dear friends. Myself, Dr. Vikrant Sudhakar Palekar. I am working as Assistant Professor in Gokhale Education Society's Arts, Commerce and Science College, Jawahar, Palghar. Welcome in the series on the topic spectroscopy. Till now, in this particular topic, we have seen various different terms related with the spectroscopy. Then we have seen also how UV spectroscopy rise with the basic principles, and in this particular session we are going to see the introductory and basic introduction regarding the mass spectroscopy. So let us revise some of the things. First of all, we try to understand what is spectroscopy. As we have come to know that it is the interaction of electromagnetic radiation with matter, and based upon that, when the electromagnetic radiation are irradiated or bombarded on the molecule, whatever the response given by the molecule is recorded in the form of spectra. So whenever electromagnetic radiation are bombarded on the molecule, the electromagnetic radiations gives various different responses in various ways, and based upon that the molecules may absorb energy or may emit energy, and whatever the absorption or emission wavelengths are there, they are recorded in the form of spectra. So based upon that we come to know structural analysis of the molecule. As in earlier session we have seen, in the UV spectroscopy, the ultraviolet wavelength of range 200 to 400 nanometers is allowed to bombard on the molecules, and based upon that the molecules gives different analysis. If you see the visible region that lies in between the 400 to 800 nanometer, and we know that combination of UV and visible spectroscopy, we see it is basically the electronic excitation of molecules, in which the molecule which is present in the lower orbitals get promoted to higher energy orbitals, and whatever the absorption or emission is there, it is being recorded, and based upon that we come to know that there are different kinds of excitation, such as sigma to sigma star, n to sigma star, pi to pi star, n to pi star. So based upon that these four excitations are recorded. Now we are going to see the mass spectrometry. In mass spectroscopy, basically we measure the atomic or molecular weight of ion based upon the separation of their mass to charge ratio. So basically mass spectroscopy gives us about the indication of molecular weight of that particular compound. So this particular spectroscopy will help to know molecular analysis based upon the charge to mass to charge ratio. If we see introduction about the mass spectroscopy, as mass spectroscopy is one of the primary spectroscopic method of molecular analysis, it allows us to determine the molecular structure and thus sample composition. So mass spectroscopy in that point of view is very important, because it helps for the molecular analysis, because it determines the molecular structure, and based upon that we can also predict the sample compositions, what are the different elements are there and how they are connected to one another. Again, if we see, in the mass spectroscopy, it is a microanalytic technique, and it requires only few nanomoles of sample in order to get the structural and molecular weight of analysis. Very few nanomoles of sample will be sufficient in the MS spectroscopy, and it will help to give us the molecular weight of the whatever sample we want to know. If we see, it involves the production and separation of ionized molecule and their ionic decomposition product, and finally the measurement of relative abundance of different ions produced. If we see in the mass spectroscopy, we analyzed basically the ionized molecules, and based upon that this ionized molecule get again decomposed, and based upon that their abundance, different ions are produced. In the next slide we will see the basic information about it. It is a destructive technique. In that, sample is consumed during the analysis. Whatever the sample we take in the nanomoles, it is being consumed in that analysis. And if we see the mass spectrum of each compound is unique. For every individual compound, you will get the different mass spectra. So it is very useful technique. So if we say it is a form of spectrometry, since it is not concerned with the discrete energy level. In the mass spectroscopy, you will not observe any absorption or emission phenomena. It is a spectrometric techniques and it does not having any discrete energy levels. Now we are going to see the basic mass spectroscopy working, how the mass spectra is obtained. In mass spectroscopy techniques, molecules are bombarded with a high energy electron beam of having source energy up to 70 electron volt. So high energy electron beam is bombarded on the analyte, and the energy of this particular impact results into the ionization of molecule subjected to the fragmentation, leading to smaller but still charged structure, that is ionized species, and broken into many fragments. So whenever the electron beam is being allowed to bombard on that particular sample, that particular molecule results into the ionization, and this particular ionization results into the further fragmentation of that molecule based upon the mass to charge ratio. So whatever the ions generated, they are termed as a molecular ions. Remember this particular phenomena, molecular ion formation. So these molecular ions are separated according to mass to charge ratio. This is very important. Whatever the molecular ions are then formed, they are separated based upon the mass to charge ratio in the analyzer, which are then applied to magnetic and electric field, and which is then connected by the detector. So whatever the mass spectrum we get, it is the relative plot of relative abundance of ions against their mass to charge ratio. So this particular spectrum we will get based upon the molecular ions. If we see basic skeleton or how the particular mass spectrometer skeleton is there, how the different components are there, we will see right now. So whatever the sample we take is that it is being taken into the probes. So that particular probe containing the desired analyte, which is to be analyzed for its structural elucidation, is taken, and it is then allowed to get inserted into ion source. So this particular ion source is having a high energy electron beam. So this particular probe is now being injecting our samples, and it is then bombarded with the electron beam. So this whatever the electron beam is there, it is then transferred inside the slits which is having ion beams. So in this particular portion there is a ion formation will be takes place. So this is, you can see here is the ion beam. So whatever this ion beam is then allowed to pass after the ion source into the magnet, and in this particular magnet these ions are separated and they are bent. So these ions are then separated, you can see here from this particular single beam, now it is being separated into different portions or different portions of ions based upon their weight. So we can easily say that they are being separated, and inside the flight tube we can see the molecule with right mass, or whatever the ions form in that, which one will be the more stable will be detected inside the detector, and whatever the we can say stable ions which are detected by the detector, then they are recorded in the form of spectra, and you get such a spectra inside the recorder. So this is how the mass spectrometer block diagram is there. So we have to remember the whatever sample, it is being bombarded with the 17 electron volt energy, then it is being converted into molecular ions, and molecular ions are further decomposed and passed through flight tube, and they are being detected on the basis of their mass to charge ratio in the recorder. So this is also the basic scale. Here is the inlet. From inlet there is an ion source where the ion formation will be there. Then this particular ion source then transfer into the mass analyzer, where the molecular ions are sorted or separated with the help of mass to charge ratio, and these sorted ions and then transferred to the ion detector, and whatever the detected ions are there, they are being recorded in the form of spectra, and what we will say that this particular is mass spectrum. Here you can see in the mass spectrum, it is the ratio of mass to charge ratio and relative abundance. Here you can see the intensity on this particular side, and here is the mass to charge ratio. So this is how we can record the mass spectrum of whatever the sample whose structure analysis want to be done. So this is a molecule, then it is bombarded with the electrons, so it results into the formation of molecular ions, or we can say radical cations, which is again then fragmented into further fragmented ions. So this is how we can analyze the sample inside the mass spectroscopy. So whatever the sample which is then bombarded with the stream of high energy electrons causes molecules to lose its electron. So whenever the electron beam is bombarded on that particular molecule, it results into the formation of ions after loss of one electron. So it then converted into radical cation. So first there is a formation of cation and species with the positive charge and unpaired electron. So molecular ion or radical cation is the species having positive charge and one unpaired electron. So if you see the example, suppose methane molecule, here you can see CH4, it is being bombarded with the electron. So what will happen during the, if we analyze the mass spectrometry of the methane, so what will happen, it is irradiated with the electron. So this particular methane molecules is, as it is having octet is complete of this particular carbon, it will lose one of the electron. So what will happen, after loss you can see that after loss there is a formation of positive charge. So here we can say this particular is molecular ion having mass to charge ratio up to 16. So molecular mass of methane is 16. So you will get 16 plus loss of 2 electron. So 1 electron which is being irradiated and 1 which is being lost. So 1 plus 1 equal to 2. So this is how you get. Here is the point to be noted. Formation of molecular ion of methane. If we take the example for the ethane, so what will happen, ethane is irradiated with the electron. So what will happen, one of the electron from here will be lost and it will result into the formation of molecular ion having mass to charge ratio equal to 30. So what will happen, again this will lose into one more loss of proton, it will result into the formation of mass 29. It will again get fragmented into this particular fragment, but it will not detected by the mass. Only the stable ions which are having stability, they are only detected. So molecular ion will help us to know the molecular weight of that particular desired compound which is to be analyzed. So 30, the molecular weight of the methane is 30, C2H6, 24 plus 6, 30. Now here we will see some of the important terms related with the mass spectroscopy. First term is very important, that is known as molecular ion peak, that is also being called as a parent peak. What is this parent peak? Due to the impact of high energy electron beam, whatever the neutron molecule, it loses an electron and resulting into the formation of radical cation. And whatever the radical cation is formed, or what we can say molecular ion, is being called as a parent peak. So molecular ion has mass according to the molecular weight of the compound from which it is generated. So we have to remember molecular ion peak or parent peak is equal to the molecular weight of the compound which is to be analyzed. So this particular molecular ion is obtained by the loss of one electron from the molecule. So this is to be very important. We have to remember what is molecular ion peak. Suppose in case of the ethanol, as we know ethanol is having weight up to 46. If you see the mass spectrum, here you can see this particular first line, then this is a second line. So this is a line for the molecular ion peak, and this particular peak will be called as a molecular ion peak, and that is equal to the 46. And this particular 46 peak will be again fragmented into different fragments, and there are some fragments you can see which is having higher intensity, which are having lower intensity. So you will come to know how why peaks are having higher intensity, why peaks are having lower intensity. So remember, molecular ion peak or parent ion peak is formed by the loss of one electron from the molecule. Now we will see the next term, base peak. Second term, base peak. It is the highest peak in the mass spectrum that is being called as a base peak. It is relatively having intensity up to 100%. So we can say base peak is the one that is being having intensity up to 100% relative to the others. So in mass spectrum of ethanol, if you see, the first peak is 46, and here you can see the next peak, which is having very high intensity as compared to the others. So this peak is considered to be a base peak because it is having intensity considered to be as a 100% or highest peak in terms of the intensity. So this is a molecular ion peak or parent peak, and this is a base peak at M to Z ratio 31. So remember, base peak is having intensity 100%. Then fragment peaks. Next term is fragment peaks. When the energy is given to molecular ion during electron impact, it further cleaves and it forms ions of low mass number, which are called as fragment peaks. So basically fragment peaks are those peaks which are being generated from the molecular ion peak or parent peak because of the further breakup of this particular molecules. If we see, the fragment peaks are having low mass as compared to the parent peak. So if you see the example of methane, it is being irradiated with the electrons. So you will get molecular ion peak at 16. Then this particular you will again irradiated with the loss of protons 15, then 13, 12. So these are the fragmented peaks which are obtained after the loss of protons. So these are the fragmented peaks of lower mass. Molecular ion is a higher mass 16. Then rearrangement ion peaks. In mass spectroscopy we also see there are some rearrangement ion peaks also obtained. How these rearrangement peaks are obtained? Because the rearrangement ions are fragmented whose origin cannot be described by simple cleavage in the parent ions, but they are formed as a result of intermolecular rearrangement during the fragmentation. So rearrangement peaks are obtained due to the intramolecular rearrangement during the fragmentation, and due to this particular fragmentation peaks are obtained due to the recombination of fragments ions. What are the fragment ions are formed? Suppose a molecular mass of 15, it combines with the another 15, so it will form some ion with weight 30. So this is being called as a rearrangement peaks because of the formation of combination of two ions. It is not obtained from the parent molecule, but it is obtained from the fragmented ions. Then next important term is isotope peaks. As we know that there are different elements are present in the nature, and in the nature if you see their abundancy, they are obtained in their isotopes. As we know that isotopes are compounds having same atomic number but different mass numbers. As in case of the carbon, C12, C13, oxygen, C16, CO17, O16, O17, nitrogen, N14, N15. So you can also see isotopic peak when you are having the such kind of elements is present in your sample. So molecular ion peak also arises from the less abundant molecule containing heavy isotopes. As we know that the isotope they are having in lesser percentage as compared to the normal one. This is an abundance percentage normally, and this is a, you can see it present in very small amount, less than 1%. So the compound containing carbon, oxygen, nitrogen, chlorine, bromine, etc. show isotopic peaks. So if we see the mass spectra, you majorly observed M plus and M plus 2 peaks. What is M plus 1? As we can see, in case of the carbon, it is having C12 and C13. If suppose C13 is present in 1%, then you can expect M plus 1 peak. Suppose is having 30 molecular weight, let us say suppose 30. So you can, the parent peak must be expected as 30, but you can also get one more peak at M plus 1 value, that is at 31. Or in some cases also you can observe M plus 2. So molecular ion plus 2. So in case of the chlorine and bromine, you can observe M plus 2 peaks, because chlorine, if you see the natural abundancy 75.77% as a C35, but you can also see C37. In case of the halogens, chlorine and bromine, you can see the isotopic form present is more. So in case of the chlorine and bromine, you can observe M plus 2 peaks. Suppose C35 and C37, Br79 and Br81. So M plus 2 peak is also observed. So isotopic peaks are also very important in a compound which contain isotopes in their isotopic elements, basically carbon, oxygen or halogens family majorly present. So go through this particular introductory part of the mass spectrum. Try to understand the basic concept, what is base peak, molecular ion peak, isotopic peaks, and how what is the basic principles of mass spectroscopy. With this particular session, we will stop here. In the next session, we will see some another terms related with the mass spectroscopy. Till then, thank you very much. Goodbye.